Our planet was born in violence and grew with disaster. 4 billion years ago, primitive life may have been drifting in the oceans, but disaster loomed. The seas were lost to intense heat, yet science tells us life survived. Deep underground, it waited for the oceans to return. Life's goal is to survive, no matter what. And survive it did. First through fire, and then through ice, on a miracle planet. Today, New York is a thriving cosmopolitan city, one of the great cities on Earth. Yet 20,000 years ago, this whole area was covered by vast sheets of ice. Glaciers ground their way through Central Park. Large rocks that have no right to be here. It's as if they were dropped erratically by some mythical giant. Before geology was a science, it was recognized that they were from another place. Some thought they were the debris carried by the waters of Noah's flood. They were carried by water, but not liquid water. Ice. To the north, Greenland is still a country of ice. Large rocks locked in glaciers are slowly transported away from where they were originally formed. Glaciers move very slowly. Their forward motion can be measured in years rather than in distance. But when the ice melts, the cargo it carries is dropped. Geologists call these rocks erratics, or dropstones. For science, they are important pieces of evidence. They give clues to the evolution of life. Erratics are found across the globe, and they are proof as to which parts of the Earth were once covered by ice. 20,000 years ago, some parts of the world were locked in ice. In Canada, near Lake Huron, there is evidence of a far earlier ice age, when the entire globe may have been frozen. Mike Hailston, a district geologist with Canada's Ministry of Northern Development and Mines, knows where to find rocks that predate the last ice age by billions of years.
This is the one that I wanted to show you. It's an Archean granite boulder stuck in a rock that's 2.4 billion years old. It's a diamictite formed from a glacial action that occurred 2.4 billion years ago.
Throughout the region, there are rocks and gravel sediments that really have no place in local geology. They are all between 2.2 and 2.4 billion years old. Older rocks are found in younger strata, as if the Earth has constantly recycled its crust. The rocks have been moved by continental drift, as well as by glaciers. To try and locate where they originally came from takes us back into the past. Glacial sediments over 2 billion years old have been found in at least 7 different parts of the globe. Until fairly recently, trying to pinpoint where they came from has been purely educated guesswork. Namibia in southern Africa is an ancient landscape carved by wind and erosion. But glacial sediments also show that ice once played a major role. Now hot and dusty as well as isolated, it is a hard country to work in. For geologists, though, it can be a paradise. Dr. Joseph Kirschvink is from the California Institute of Technology. His specialty is magnetics. The Earth is surrounded by magnetism produced by its own magnetic field, the way compasses work. Long ago, as they formed on the Earth's surface, the jagged rocks in this riverbed were molten lava.
These are lavas that erupted about 2.2 billion years ago during one of the largest snowball Earth glaciations. It's kind of neat. It erupted underwater in seawater, and as the magma cooled, the magnetic minerals in the rock were able to record the direction of the magnetic field at the time. The lavas here actually are about 1,000 meters thick total, and by looking at the magnetic directions in this pile of rock, we were able to calculate very precisely what the latitude was at the time they erupted. And the amazing thing is that it was only 11 degrees. It's kind of like the latitude of Costa Rica now. And that means that the entire planet must have been under ice, because if it's cold on the equator, it has to be colder towards the poles.
Molten lava contains many minerals which are magnetized. As the lava flows, these minerals follow the magnetic force of the Earth. Once it cools, the magnetic direction of that moment is fixed forever. It is then possible to locate exactly where the rock was formed. To do this, one matches the magnetic history of the rock with the angle of the lines of geomagnetic force that surround the planet. Once that has been determined, the latitude can be fixed. In a tightly shielded room, the faint magnetic records held in the rock samples are detected. At the center of the screen is the pole. The further away a point is from the center, the closer it is to the equator. When the samples from Namibia were analyzed, their magnetic compasses pointed to the fact that they all had originated near the equatorial regions, closer to the equator than Hawaii and Guam are today. This confirms that over 2 billion years ago, there were glaciers near the equator.
To have glaciers there at that latitude implies that it has to be colder as you go north. Hence, the entire Earth, right down to the equator, had to have been frozen.
Not once, but twice, for glacial sediments in strata dated between 800 to 600 million years ago. From this data, Dr. Kirschvink put forward the proposal that the Earth had been completely covered in ice at least twice in its history. It was called the snowball Earth, and like many scientific theories, this one is hotly debated. Children always enjoy scrambling around looking for rocks.
See, now remember I told you you've got to hold it close to your eyes. That means you're going to go right down on the rock.
And there are few better teachers than Dr. Paul Hoffman of Harvard University. For years now, his passion has been geology, and he is also a keen advocate for snowball Earth.
The impact of the snowball events would, of course, be much more severe because organisms might try to escape towards the tropics, but eventually in the oceans, the ice will completely envelop the tropics. Because this ice is flowing, it will move into the tropics and meet at the equator.
Working with scientists at the University of Tokyo, a computer simulation was carried out to show what would happen to today's world if a snowball Earth event were to occur. begins to cool, frigid winds would reach much further into the tropical regions. Arable land would start to freeze. Today there is life across the globe. This was not the case in the two previous snowball events. At 35 degrees north, Tokyo is just a little further south than New York. Ice up to 1,000 meters or 3,000 feet thick would bury the city. At first, any life that could not find shelter would freeze to death. At the start, the glaciers would move slowly. It would take millions of years for the ice to reach a latitude where Hawaii and Cuba are. But from there to the equator would take only a few decades. Paul Hoffman thinks that the sea might freeze down to a depth of over half a mile. Some life might escape under the ice, but only for a while. For sunlight would be cut off, and the base of the food chain would die. It would seem as if the world would become a dead planet. But life is present on the Earth today, so where could it have taken refuge?
And an even more extensive, and we think very interesting, place where life would have survived would be in cracks that would always develop because the sea ice is flowing, whereas the ice that is at the coast would be frozen and locked in place. And therefore there will always be a shear between the glaciers flowing in the ocean and the land-fast ice. And so cracks will continually open and then freeze and then open and freeze and open and freeze. And there's a very rich biota that lives in cracks and in channels of salty water that get enclosed within new sea ice.
How a snowball event gets started is still not fully understood. But strangely, it may have something to do with the gases which keep the Earth warm. Without these gases, the average temperature would drop well below freezing. Moderate levels of carbon dioxide help to keep the planet warm. But there is evidence which suggests that prior to the first snowball event, these levels were far lower. If so, what kept the planet warm? A large area of wetlands and swamp in the southeast of the United States can give some clues to the makeup of Earth's early atmosphere. The Okefenokee National Wildlife Refuge covers an area of 400,000 acres. The shallow, warm water is sometimes only knee-deep. Beneath the surface, the swamp floor is soft and spongy.
Now, right here is the Loblolly Bay. Is this tree in front of it?
Don Berryhill was a science teacher. Now, as a volunteer guide, he enjoys sharing both his love for the area as well as his love for science.
See where I'm digging down here? Look what's coming out. All right, that's a gas that's produced by the bacteria and the fungi down there.
As soon as the bottom of the swamp is disturbed, gas bubbles escape.
Now, that's the purpose of having it on the stick, so we can get it. No, not yet. We're losing our gas.
It is a highly flammable gas called methane.
There, you good, you got it. All right.
This gas is sometimes used in households for cooking. But here it is produced by microbial life
There it is.
called methanogenes.
Ta-da! That's a ta-da!
Unlike so much life on the planet today, methanogenes don't rely on sunlight for energy. Instead, they get their energy by breaking down nutrients and making methane as a waste gas. Scientists believe that methane was the greenhouse gas which kept the early Earth warm. As methane bubbles to the surface, we now know that climate change is nothing new and is a specialty for Dr. Jim Casting of Pennsylvania State University, who is a leading researcher in atmospherics. His research shows that if there was no carbon dioxide in the atmosphere, methane alone could keep the climate well above the freezing level.
But if you go back prior to the rise of oxygen around 2.3 billion years ago, then methane levels could have been much higher. There might have been 1,000 parts per million of methane, and that by itself would be enough to counteract the reduced luminosity.
He believes that the atmosphere then would have appeared reddish because of the high methane levels. At that time in the planet's existence, there was no life on land, no plants, no animals. The only life forms were microbial and lived in the oceans. Methanogenes belong to a group of microbes known as the archaea, a different branch of the tree from which the microbes were eventually to evolve to higher life. They belong to the family Eukarya, and they are the ancestors of life today. Then a totally new organism emerged into the oceans. Perhaps a single cell mutated when reproducing. It's something we'll never know. But these cyanobacteria were to change the world. They were the first organisms to convert sunlight into energy and as a byproduct produce oxygen, a process known as photosynthesis. Oxygen was released into the atmosphere in huge quantities. And in those days, there was nothing that could use it. Dr. Casting thinks that it reached a level when its reaction to methane accelerated, eventually eliminating methane from the atmosphere. Over time, the world would change from its reddish color to blue. With nothing to stop it, oxygen production continued unabated for millions of years.
If our story about the rise of oxygen is correct, then this is anti-Gaia. Life destabilized the climate. These little microorganisms, caused the rise of oxygen, caused the decline of methane, and triggered a global glaciation, which, may have come close to wiping them out. But, the Earth system, fortunately, is very resilient, and it manages to recover from global glaciations in a way that we think we understand.
Then the sun was smaller than it is today, so with the warm blanket of methane removed, the world began to cool. There were no other greenhouse gases to warm it, so slowly the planet began to freeze. Life had kept the planet warm, and now life was bringing chaos and disaster.
What we have learned is that when there is a mass extinction, in the aftermath, those organisms that are quick off the mark and can take advantage of empty ecospace and seize those places, even if they're not the most advanced or most suitable organisms, if they can get there first, and establish their foothold, they can be very difficult to dislodge. And so after each mass extinction, there's a new biota which takes hold and becomes ascendant for a long period of time, perhaps until the next mass extinction.
Scientists believe that if there were snowball events then, they must have persisted for millions of years. During that time, the face of the planet would have seemed a frozen and desolate wasteland, as parts of Iceland are today. There was perhaps a chance that life could survive in water beyond the oceans, living from the heat and energy that comes from the Earth itself. Iceland is known for its volcanic and thermal activity. The land has only a thin crust above the heated mantle of the planet. It sits very close to awesome power and force. Hot springs are found across the island where the heat of the Earth forces its way out. Places like these could have been a safe haven for microorganisms which like the heat, the thermophiles. Dr. Viggo Martinsson and his team work for a company which hopes to use rare microbes for research.
Temperature field, so very steaming coming up from that deep down in the earth.
And it's places like this where thermophiles can live. Where the water bubbles out, it's too hot for just about any living organism. But cooler edges are full of bacterial life.
Look, this is great. This is all covered with cyanobacteria. This is rich to all kinds of species.
The life in these pools is made up mainly of bacteria which photosynthesize. The microbes cluster together to form thick mats. The earliest evidence of organisms like this appear before the first snowball event. Even then, the green filaments of cyanobacteria would have clustered together. Around them are other microbes able to tolerate high temperatures, living off the nutrients. Perhaps this was also where our distant ancestors found shelter from the ice.
The geothermal area is a refuge for life. Life like this, where you can find cyanobacteria, or you can also find all different kinds of broad range of diversity of different kinds of bacteria.
Maybe the planet needed a disaster like a snowball Earth to let new forms of life take strides forward. Shortly after the ice melted, life had changed greatly, even if it was still minute. This is a microorganism known as chonoflagellate. It's an unusual group of microbes which cluster together in colonies. These are the closest known ancestors of animals and us, and for the next billion years, life stood still. There were no further advances. If we were to compare the Earth's history to a single year, then microscopic creatures were life's main force up until mid-November. But the second snowball event, about 600 million years ago, was to change that forever. Life's history is painted in its rocks. This barren wasteland was once the bed of an ancient ocean. Namibia in southern Africa is mostly a harsh and arid land, but this means that the rocks that lie upon the surface are relatively undisturbed by water erosion or moved by flooding. Etched into some of the scattered rocks are strange shapes and forms.
We come to this section with the rock.
As well as here, on a Namibian farm,
That we are looking for.
similar fossils have been found in Siberia,
You've got the
Australia, and
negative
Newfoundland.
impression there. On the other side, you see the positive outcrops of the same fossil.
Fossils, certainly. But fossils of what?
For us as laymen, we didn't know what it was. It could be anything from a fish or a fern. Actually, it looks more like a fish. But then later on, even the scientists weren't sure whether it was a plant or whether it was a living organism.
These fossils date back to the end of the second snowball event, and they were neither fish nor leaf. They were the first living creatures larger than microbes to appear on the planet. These were giant steps forward in evolution. This one was named Pteridinium, and scientists think that it may have lived on the sea floor, half buried in the mud. They have a body shape and form which resembles nothing living in the modern age. So too with this strange creature found in Siberia and named Georgia. A stone with 5 strange fossil marks is a record of this animal's movements on the seafloor. This is the first time in the history of the planet that a living creature moved with direction and purpose. This one too comes from Siberia and has been named Kimbarella. It had a snail-shaped body and a strange long protrusion which allowed it to feed from the seafloor. The first time that any creature had dug in the mud, releasing nutrients back into the water. This period after the second snowball Earth is called the Ediacaran, after a range of hills in South Australia where similar fossils were found. And somewhere among these creatures was the ancestor for modern life. It might have been this, a fossil discovered in Australia in 2003. Some think here is evidence of a backbone, perhaps making this creature the size of an adult small finger, the predecessor of the vertebrates. We can only speculate as to how it lived. After 3 billion years of life, it was amongst the first creatures which would be visible to the naked eye. Both snowball events seem to have been crucial for evolution. The second could not have happened without the first, which saw the rise of organisms like this eukaryote. Although still tiny, it was 1,000 times larger than the early microbes. The mystery yet to be solved was how the ice melted. Once a planet like the Earth was frozen, it would reflect sunlight back into space and so remain frozen. What did happen to melt the ice? A hint can be found in this mine in the Kalahari region of South Africa. This is the largest deposit of manganese to be found anywhere in the world. All the ore was laid down on the bottom of an ocean floor just when the first snowball event ended. Dr. Joseph Kirschvink from Caltech, who first published the snowball Earth hypothesis, wondered if this deposit was in some way connected to the melting of the ice.
Actually, solid samples. I think maybe we could orient that one.
All the manganese in this mine were of manganese dioxide, which can only form with oxygen. The oxygen molecules bond with the manganese to form manganese dioxide. This can be easily seen in a simple experiment. First, a solution with dissolved manganese was prepared. Bubbles of oxygen are fed into the solution, and it begins to turn brown, then black. Oxygen and manganese then bonded to become manganese dioxide, which falls to the bottom of the tank. This is what is thought to have happened during the first snowball event.
Only molecular oxygen, free molecular oxygen like we have in the air, is able to oxidize the manganese and make it fall out as this black rust. And what we're standing on today and what you can see here is the evidence of a massive amount of oxygen being put into the environment just at this time, just after the snowball.
He believes that the oxygen in the atmosphere of the early Earth was almost non-existent. After the first snowball event, it increased to around 1%. After the second event, it rose to 20%, close to the level in the atmosphere today. Oxygen molecules also produce an enormous amount of energy. And because energy became available, life was able to evolve into larger and more complex forms. Yet the questions kept coming.
When we were faced with this data, I had to sit back and say, okay, what fundamental things could be wrong? If the Earth did freeze, it was clear that the equilibrium ice in the oceans would be 1 to 3 kilometers thick. The entire surface of the planet would be white, frozen. Life would have obvious problems surviving, maybe would not go extinct. But it occurred to me that a frozen surface would not influence the working of geology. In particular, plate tectonics and volcanic activity would not stop. And it just hit me one morning that, oh, of course, the carbon dioxide from volcanoes would continue to build up in the air.
Volcanic gases contain large amounts of carbon dioxide, which normally dissolves into the seawater. But since the world was covered by ice, the carbon dioxide had nowhere to go but up. It continued to build to levels which may have been 2,000 times higher than those of today. As the Earth warmed, the ice began to melt.
You go from an average temperature of going down to minus 50, almost to plus 50. And at that point, you melt the ice extremely rapidly.
It was the Earth's own forces which brought the snowballs to an abrupt and dramatic finish. One study has suggested that when the surface of the sea reaches 45 degrees Celsius, about 110 Fahrenheit, it would trigger weather patterns that the world has never seen before or since. Temperature differentials would cause massive hurricanes to build. These hyperhurricanes would generate waves the height of buildings. All this activity boosts oxygen production. Normally, nutrients which vent into the oceans from the Earth would settle back to the bottom or be consumed by bacterial life. In deep water, microbes aren't harmed by a surging ocean from the hyperhurricanes. Many are transported from the depths to shallow waters.
But to imagine a hyperhurricane where you have waves maybe 100 meters in height, all of Florida would be wiped out. I mean, the waves would crash over and remove Florida. I mean, we have never seen something like this. So it's difficult to imagine.
Then when the winds died and the ocean calmed, the sun would heat the shallows. With sunlight and nutrients, photosynthetic microbes would explode in numbers, releasing yet more oxygen. The algal bloom would be so great that the seas would turn green. More and yet more oxygen would be pumped into the environment. The strength of life, which had survived 2 snowball Earth periods, had changed the planet and was about to embark on a new chapter, but this time with abundant oxygen. Oxygen was the molecule that would change the world.
If Earth had never experienced these glaciations, life could have been quite different. Life on Earth might still be limited to the bacterial grade. We could still be just a planet of slimy oceans and stromatolites with nothing big enough to move and do things.
And oxygen allowed one more innovation without which larger animals could not exist. That was collagen, the scaffold which cells use to bind together. In this experiment in Japan, synthetic collagen is mixed with cells in a culture. These cells with collagen on the left of the screen multiply vigorously, while those on the right are static. Cells begin to cluster together, as they must in every large living creature. Vitamin C was added to create an environment in which it would be easier for cells to secrete collagen. A thin tissue-like skin has formed in the dish. Collagen is a unique material which is produced by all animals, including humans. It helps cells to shape tissue. When a cell multiplies, it assembles collagen that it has secreted into a fine net-like structure. As the cells divide and multiply over and over, the collagen allows them to create different shapes and tissues. Dr. Kenneth Tao of the Smithsonian Institute believes that it is collagen which gave shape to life after the second snowball Earth. And since collagen is made from many atoms of oxygen, it could never have been produced if atmospheric oxygen had not been present. After the first snowball event, it's thought that collagen might have been available when oxygen became part of the atmosphere. But then, most of it was used for respiration. After the second event, oxygen rose dramatically.
Because collagen is formed with two amino acids that do not appear in the genetic code, it seems to me that there was no way that evolution could find to make something similar to collagen without these amino acids, and therefore it probably took a long time for this to happen, and that is part of the problem. The other part of the problem is that molecular oxygen is needed to make these amino acids that are important to make the collagen fibers that are important to allow bodies to increase in size, for muscles to develop and be held together, for skin, for cuticles, and all of these things.
So many things could have happened differently. The trillions of cells which make a human body are bound together by collagen. And without collagen, and without oxygen, we would not be here today. After the first snowball event, there was little change in life. After the second, oxygen levels soared, and the first complex life appeared, expanding horizons and leading to higher and yet more complex life. These strange creatures which evolved from the snowball events would not last long, just a few tens of millions of years, before a new life force took over. Now, life could never step backwards, and it was in shallow seas around a vanished continent where the next step would be taken. The fossil evidence shows a rich environment of corals and fish and other marine creatures. Corals need warmth and sunlight, and there would have been an abundance of both. At this time in the Earth's history, we think that our closest ancestor was this fish, called Arandaspis. It's the oldest known fish with a backbone. Without fins, it would not have been a good swimmer. They would have been filter feeders, sucking up microbes from the coral on the sea floor. As yet, no animal had developed a jaw, so probably the deep waters were not a suitable niche for them to live in. But that would change. There was a rich variety of life. Amongst it were numerous trilobites, small, segmented, and hard-shelled creatures. Some were free swimmers, while others crawled along the sea floor. When the change came, these creatures left clues, which were picked up by an English paleontologist. This quarry in Shropshire in the west of England was once near the equator and a part of the Iaptus Sea, an ancient sea which vanished some 400 million years ago. Marine fossils, and trilobites in particular, are Dr. Richard Fortey's driving passion.
Oh, lovely. Look at this one. It's a chain coral.
The abundance of fossils in the coral record suddenly vanished, a sure sign that something drastic happened to this environment. There were other noticeable changes to life as well. Trilobites began to alter their appearance. Some began to grow protective armor.
It's almost certain that they were a response, defensive response, to being under greater pressure from a variety of predators. Life, in other words, got a little bit tougher for the trilobites. And one of their responses was to increase their protective armor.
Life undertook a new development in body shape. Suddenly in the fossil record we find fish like this, sleek, fast predators. The world began to be divided into predator and prey. It was the start of the arms race on the miracle planet. slowly. Their forward motion can be measured in years rather than in distance. But when the ice melts, the cargo it carries is dropped. Geologists call these rocks erratics, or dropstones. For science, they are important pieces of evidence. They give clues to the evolution of life. Erratics are found across the globe, and they are proof as to which parts of the Earth were once covered by ice. 20,000 years ago, some parts of the world were locked in ice. In Canada, near Lake Huron, there is evidence of a far earlier ice age, when the entire globe may have been frozen. Mike Hailston, a district geologist with Canada's Ministry of Northern Development and Mines, knows where to find rocks that predate the last ice age by billions of years.
This is the one that I wanted to show you. It's an Archean granite boulder.
But glacial sediments also show that ice once played a major role. Now hot and dusty as well as isolated, it is a hard country to work in. For geologists, though, it can be a paradise. Dr. Joseph Kirschvink is from the California Institute of Technology. His specialty is magnetics. The Earth is surrounded by magnetism produced by its own magnetic field, the way compasses work. Long ago, as they formed on the Earth's surface, the jagged rocks in this riverbed were molten lava.
These are lavas that erupted about 2.2 billion years ago during one of the largest snowball Earth glaciations. It's kind of neat. It erupted underwater in seawater, and as the magma cooled, the magnetic minerals in the rock were able to record the direction of the magnetic field at the time. The lavas here actually are about 1,000 meters thick total, and by looking
Our planet was born in violence and grew with disaster. 4 billion years ago, primitive life may have been drifting in the oceans, but disaster loomed. The seas were lost to intense heat, yet science tells us life survived. Deep underground, it waited for the oceans to return. Life's goal is to survive, no matter what. And survive it did. First through fire, and then through ice, on a miracle planet. Today, New York is a thriving cosmopolitan city, one of the great cities on Earth.
Stuck in a rock that's 2.4 billion years old. It's a diamictite formed from a glacial action that occurred 2.4 billion years ago.
Throughout the region, there are rocks and gravel sediments that really have no place in local geology. They are all between 2.2 and 2.4 billion years old. Older rocks are found in younger strata, as if the Earth has constantly recycled its crust. The rocks have been moved by continental drift, as well as by glaciers. To try and locate where they originally came from takes us back into the past. Glacial sediments over 2 billion years old have been found in at least 7 different parts of the globe. Until fairly recently, trying to pinpoint where they came from has been purely educated guesswork. Namibia in southern Africa is an ancient landscape carved by wind and erosion. Yet 20,000 years ago, this whole area was covered by vast sheets of ice. Glaciers ground their way through Central Park. Large rocks that have no right to be here. It's as if they were dropped erratically by some mythical giant. Before geology was a science, it was recognized that they were from another place. Some thought they were the debris carried by the waters of Noah's flood. They were carried by water, but not liquid water. Ice. To the north, Greenland is still a country of ice. Large rocks locked in glaciers are slowly transported away from where they were originally formed. Glaciers move very